Hello everyone, this is Gregory from ChemCore. This is going to be the explainer video for the formal charges worksheet that is available in the description below. If you didn't have a chance to do it or check the answer key, that will all be in the description. And the topic video for formal charges will also be in the description below. Let's get started. I kind of want to start with our HONC mnemonic, like we did in the video. So this is hydrogen and halogens like to form one bond. O, oxygen, likes to form two bonds. N, nitrogen, likes to form three bonds. And then C, carbon, likes to form four bonds. Handwriting not too pretty. And I think this will help us move on with the rest of the problems, and maybe we can refer to this mnemonic to solve some of these problems. Draw the possible structures of a carbon with a formal charge of +1. In the video we talked about carbon with a positive charge is 3 bonds and no lone pairs. And so what this question is asking us is, let's draw all the possible combinations in which carbon has 3 bonds and no lone pairs. The simplest one, and actually the example in the video, was 3 single bonds and no lone pair, giving carbon a formal charge of +1. We can also arrange the bonds to give 1 double bond and 1 single bond, giving carbon a formal charge of, again, +1. The last combination is we can give carbon just a triple bond and no lone pair to give it a formal charge of +1. These are all your possible combinations of carbons that, arrangements of bonds to form a carbon with a formal charge of +1. Carbon with a formal charge of 0 we talked about was just 4 bonds, like according to our mnemonic, right, HONC. And we should not have any lone pairs with carbon with 4 bonds. So what this question again is asking us, let's draw all the possible combinations of carbon with 4 bonds. And so one of these combinations, and frequently seen in the videos that we talked about, actually in the Lewis structure video, was carbon with just 4 single bonds. We can also try to draw a double bond by doing a double bond and 2 single bonds. And then we can also stick with double bonds by just making 2 double bonds. And finally, we can make carbon with one single bond and 1 triple bond. And all of these have a formal charge of 0, so neutral. The next problem, draw the possible structures of carbon with a formal charge of -1. We talked about carbon has a formal charge of -1 when it has 3 bonds and 1 lone pair. So again, let's try to draw all the possible combinations in which we have carbon with 3 bonds and a lone pair. In this case, we can draw carbon with, again, just single bonds and a lone pair. This will have a -1 formal charge. We can also try arranging a double bond, and then we still have another single bond to form, again, a carbon with a formal charge of -1. Then we can just do a triple bond and a lone pair to once again form a carbon with a formal charge of -1. Now we're finally moving away from oxygen and away from carbon and toward oxygen. And this question is asking us, draw the possible structures of an oxygen with a formal charge of +1. According to our HONC mnemonic, nitrogen and oxygen is pretty easy to do. An oxygen with a formal charge of +1 will have 1 more bond than it likes. So if it likes 2, an oxygen with a formal charge of +1 should have 3 bonds, and subsequently just 1 lone pair. And so an oxygen with 3 bonds and 1 lone pair will have a formal charge of +1. And so we can arrange this in a couple ways. We can have oxygen with just single bonds, something like this, and a lone pair. And in this way, it'll have a formal charge of +1. We can also have oxygen with a double bond and a single bond, and then again a lone pair. This will also have a formal charge of +1. We can also have an oxygen with a triple bond, forming 1 lone pair and has a formal charge of +1. Next question, draw the possible structures of an oxygen with a formal charge of 0. If it has a formal charge of 0, it should follow our HONC mnemonic, in which oxygen will have 2 bonds. And so we should have 2 bonds and 2, not 1, 2 lone pairs. In this format, we should have oxygen with just single bonds, and this is maybe could bring up some the first thing you may think of when looking at this molecule is H2O. I know that's what I think of when I think of something that looks like this. Another arrangement that we can make is just a double bond, and by doing that and 2 lone pairs, we again form a formal charge, an oxygen with a formal charge of 0. An oxygen with a formal charge of -1 should have just 1 bond and 3 lone pairs. And so realistically, there's really only one possible way to arrange this. There's only one way that oxygen can have 1 bond, and this doesn't change much. In this way, it will have a formal charge of -1. That's pretty common to see, actually. We'll move on to when this becomes really important. The next question, draw the possible structures of a nitrogen with a formal charge of +1. According to our HONC mnemonic, if nitrogen had a formal charge of +1, it must have 1 more than it likes, which means it should have 4 bonds. Meaning it should have 4 bonds and 0 lone pairs. In the next question, draw the possible structures of a nitrogen. This should actually be -1. I changed it in the answer key in the worksheet, but not in this document. A nitrogen with a formal charge of -1 should have, according to our mnemonic, 1 less than what it likes, which means it has 2 bonds and 2 lone pairs. And so nitrogen can be organized with 2 single bonds and 2 lone pairs, giving it a formal charge of -1. You can also just have a double bond and a negative formal charge, as well as its lone pairs, forming a nitrogen with a formal charge of -1. A nitrogen with a formal charge of 0 should just have 3 bonds and 1 lone pair. Meaning we can organize this as single bonds. This has a formal charge of 0. We can do a double bond, also formal charge of 0. Let's try a triple bond, also formal charge of 0. And the last of this series, draw the possible structures of a nitrogen with a formal charge of +1. This should have 1 more than what it likes, meaning it should have 4 bonds and no lone pairs. So let's try to arrange them as single bonds. This has a formal charge of 0. We can also try the double bonds, also 0. Let's try another one with double bonds, so 2 double bonds this time. And then our last one, a triple bond and a single bond, should have, once again, a formal charge of 0. Of +1. My apologies. And all of these should have a formal charge of +1. Moving on. For each of the following compounds, draw the Lewis structure and assign the formal charge for each element. I'm not going to be really counting the valence electrons to form these Lewis structures. I'm mostly going to be using our HONC mnemonic and a little bit of intuition. But if you struggle with drawing these Lewis structures quickly, take your time and use the valence electrons, count them up, and make your Lewis structure make sense. Nitrogen, I see a negative charge, and the problem with a negative charge in a molecule is we kind of don't know where it's coming from, right? It has to be a combination of the nitrogen and 2 hydrogens in some combination to form a net of -1. And drawing this Lewis structure will let us understand where this negative charge comes from. I know that hydrogen will only have one bond, so it's probably unrealistic that hydrogen will have that negative charge. And if we have just two single bonds, we can arrange nitrogen with two lone pairs. With two lone pairs, giving this nitrogen the -1 formal charge. The next one, let's try to put carbon in the middle. And if we organize the elements around it, like so, we will generate a molecule that has oxygen has everything it wants, so two bonds and two lone pairs. This oxygen also has everything it wants, two bonds and two lone pairs. But this oxygen doesn't quite have enough, right? It only has one bond and ends up having three lone pairs, meaning that this oxygen will have a formal charge of -1, and the rest should have a formal charge of 0, right? I specify the rest of the molecules in the other document, in the answer key, but I'm just going to write the molecule that really matters for us in this one. I hope at this point you guys are familiar with seeing hydrogens arranged around carbons. This becomes a very... you're going to be drawing carbons with hydrogens around them for a long, long time. So let's try to arrange the hydrogens around our carbon with one bond, connecting to the other carbon. And then let's try to give carbon everything it wants. So it wants 3 more bonds. Yes. And this would match up if you counted the valence electrons. But every molecule in our Lewis structure has the exact amount of bonds that it wants, right? Both carbons have 4 bonds. All of the hydrogens have 1 bond. And nitrogen has 3 bonds, subsequently a lone pair. So every element in this Lewis structure should have a formal charge of 0. The next problem, the hydronium ion. This is what it's called. You should be familiar with this from your Gen Chem course. We'll put oxygen in the middle. This should not be a new Lewis structure to see if you took Gen Chem or some form of Gen Chem. This forms just 1 lone pair in the oxygen. And all the hydrogens have the exact bonds that they want, right? 3 bonds. But oxygen has 1 more bond than what it likes, right? Instead of 2, it has 3. And so it has a formal charge of +1. And it makes sense because this adds up to plus in the total molecule. NO, this is kind of a tricky Lewis structure. It's a common Lewis structure that professors like to give out. If we try to give oxygen everything it needs, that's great. Works out. However, nitrogen ends up having, you would like to draw a lone pair, but then you notice that you're 1 over on the valence electrons. And so what happens is that you would form a radical, right? Just 1 electron alone. This is what it works out to. There's a couple variations to this Lewis structure that you might find online, but this is the general, most stable Lewis structure, and we'll talk about why that is in a future video. Oxygen has the exact bonds that it wants. However, nitrogen kind of has like a little variation to its Lewis structure than what we're used to, right? We're used to 2 bonds and maybe 2 lone pairs to give it a formal charge of -1. But this one is a little weird, right? It's a lone electron. And so I really suggest count your valence electrons and subtract, and you would end up with, once again, a formal charge of 0 for both nitrogen and oxygen. So the net is 0, and that makes sense according to our molecular structure that they gave us. The next one, phosphorus, should probably be in the middle, surrounded by oxygens. Okay? And according to phosphorus 5, right, the little mnemonic that I gave you, we're going to want phosphorus to have 5 electrons, or 5 bonds and electrons combined. And so if we were to give phosphorus 3 bonds and then 2 electrons, it would satisfy phosphorus's what it wants, right? But the other oxygens would end up with 1 less bond than they prefer, right? So they have 1 bond and 3 lone pairs each, giving them each a formal charge of -1. And if they each have a formal charge of -1, well then combined they should have a formal charge of -3. And that makes sense, right? The net formal charge, the net charge of the molecule is equal to the addition, the sum of all the formal charges of the elements in the structure. NO3, we know that nitrogen likes 3 bonds, and we have 3 oxygens, so, I don't know, common sense would put nitrogen in the middle, surrounded by the oxygens, and 1 bond each, to try to give nitrogen what it wants, and it'll have another lone pair in there. So nitrogen should have a formal charge of 0. But the oxygens have 1 less bond, again, 1 less bond than what they prefer. So they have each 1 bond, that was a little, doesn't look that good. Let me erase that. One bond, I cannot draw these lone pairs. 1 bond and 3 lone pairs, giving them each a formal charge of -1. And that makes sense because, once again, the sum of all the formal charges in the molecule adds up to the to the net charge of the molecule. The next problem, SF3. If we surround sulfur with 3 fluorines, and remember that sulfur 6, right, that little mnemonic that I gave earlier, sulfur wants 6 total electrons in bonds and lone electrons combined. So if fluorine gives 1 bond to sulfur, right, because it's a halogen, it'll probably give 1 bond. And we fill up sulfur with 2 more lone pairs, it satisfies sulfur's internal structure. Fluorine would have 3 lone pairs each. So fluorine has exactly the number of bonds that it wants. But sulfur, let's count up sulfur 6. 1, 2, 3, 4, 5, 6, 7. Instead of 6, it has 7. And so this makes sense that sulfur would have a formal charge of -1, right? And the total charge would end up being, again, -1. N2O, this next problem, the only way we can arrange this to give the molecules what they want and really make it possible, right? This nitrogen on the left has exactly what it wants, right? 3 bonds and 1 lone pair. The nitrogen in the middle doesn't quite get that. It has 4 bonds, so 1 more than what it likes, meaning that it has a formal charge of +1. And oxygen on the right, well, it has only 1 bond, so 1 less than what it likes, and 3 lone pairs, giving it a formal charge of -1. And combined, this gives a net charge to the molecule of 0, right? And that makes sense because there's no charge on the molecule as given. SCl3, we have a positive formal charge somewhere. So let's try to arrange these chlorines around the sulfur. And let's try to give sulfur the exact bonds so that chlorine's bonding is fulfilled. And so each chlorine will have 1 bond and 3 lone pairs, and that makes sense because it's a halogen, right? So it gets what it wants, right? Formal charge of 0 all around. And if we want to give a sulfur a formal charge of +1, well, if we gave it a single lone pair, it would have 1, 2, 3, 4, 5, right? We said sulfur 6, but now it only has 5 electrons around it, meaning that it has a formal charge of +1. NH4, this is a simple one. Let's try to arrange the hydrogens around the nitrogen and give a bond to each of the hydrogens pointing toward the nitrogen. This way, nitrogen has 4 bonds, 1 more than what it likes, giving it a formal charge of +1. And each of the hydrogens have a formal charge of 0. SO4 with a -2 charge. Let's try to give sulfur in the middle with oxygens all around it. And if we want to satisfy sulfur's internal bonding, let's try to give it 6. So what it could look like is 2 bonds each and then 1 bond each, giving it, so these 2 oxygens will also be satisfied, right? They have 2 bonds and 2 lone pairs. Erase that and make it look cleaner. But the oxygens looking up and down have only 1 bond, right? Meaning that they have 3 lone pairs. And this would give the oxygens each a formal charge of -1, right? Combining to a total charge in the molecule of -2. The next problem, what is the formal charge on the oxygen in the following structure? So the oxygen they're obviously referring to, there's only 1 oxygen, is the one on the right. Well, we said oxygen likes to form 2 bonds, and if it has 1 more or 3, it should have a formal charge of, well, 1 more or +1. And this molecule, oxygen, has 3 bonds and 1 lone pair. And so really quickly, we can determine that oxygen has a formal charge of +1. What is the formal charge on the carbon in the following structure? Again, this is kind of a combination that we're not quite used to seeing. So instead of using our HONC mnemonic, let's actually calculate it, right? So carbon has a formal charge, has 4 valence electrons, right? Let's use our formula. 4 valence electrons minus 2 bonds and minus 2 electrons gives a total of 0, right? So even though this is a combination that we're not quite used to seeing, this carbon should have still a formal charge of 0. In which structure does oxygen have a formal charge of +1? The easy way we can remember this is, well, oxygen should have 3 bonds and 1 lone pair to generate a formal charge of +1. And so let's try to look for all of the molecules in which oxygen has 3 bonds and 1 lone pair. I see one here, right? We have 3 bonds and just 1 lone pair. In this one, it does not, right? It only has 1 bond. In number 3, it again has 3 bonds and 1 lone pair. And again, in number 4, it also has 3 bonds and 1 lone pair. And it has what it's connected to, or the arrangement of the bonds, has it's not relative at all, right? It has no correlation to the formal charge. The formal charge is kind of no matter what the arrangement is, it will be the same. So the answer is 1, 3, and 4. All of these. In which structure, again, does oxygen have a formal charge of +1? So using the rules that we learned before, let's analyze each of the oxygens in each of these molecules. Right, this oxygen on top has 2 bonds, right? So satisfies, while this oxygen has 1 bond, right? So it should have a formal charge of -1, but it definitely doesn't satisfy what they're looking for in the problem. Each of the oxygens in number 2 have 2 bonds and 2 lone pairs, meaning that both of them should have a formal charge of 0, so we can cross this one out as well. Number 3, well, this oxygen in the center does have 3 bonds and 1 lone pair, meaning that it probably has a formal charge. Well, not probably. It does have a formal charge of -1. In number 4, again, oxygen has 3 bonds and just 1 lone pair, meaning that the oxygen has a formal charge of +1. And the oxygen on top in the last example has 2 bonds and 2 lone pairs, meaning that, well, it doesn't satisfy what they're looking for. And both the oxygens on the bottom have 1 bond and 3 lone pairs. Again, it doesn't satisfy what we're looking for. And so the only answers that we have is 3 and 4. And the next problem, in which structure does nitrogen have a formal charge of +1? This actually should be -1, right? I made a little mistake in the worksheet. Nitrogen should have a formal charge of -1 when it has 1 less than what it prefers, right? So 2 bonds and subsequently 2 lone pairs. So the only answer that really satisfies this is A. The rest have 3 bonds and 1 lone pair. So each of these would have a formal charge of 0. So we can eliminate every single one of these. The next problem, what is the formal charge of oxygen in this problem? Oxygen in this problem has 3 bonds and 1 lone pair. And so it has 1 more bond than what it prefers, meaning that it has a formal charge of +1. Which of these cases does the central atom have a 0 formal charge? Well, let's define each of these. In this one, the first, in A, we kind of have to draw a Lewis structure. And we know right away, well, fluorine has 2 bonds, right? 1 more than what it prefers. So we don't even have to calculate the formal charge. We know that it would not be 0. In this one, oxygen has 3 bonds, and they don't specify the lone pairs, but it has 1 lone pair, meaning that it has a formal charge of +1. In this one, boron actually should have 3 bonds, but if you calculate the formal charge, it'll actually have a formal charge of -1, so not 0. And nitrogen, in this example, nitrogen has 4 bonds, meaning that it has 1 more than what it prefers, and so nitrogen has a formal charge of +1 in this example. And E is the only one where the central atom has a formal charge of 0. Carbon has 4 bonds, no lone pairs, and so this is the only answer in which the central atom has a formal charge of 0. Which compound contains a nitrogen with a positive formal charge? Nitrogen, in the first example, has 3 bonds, and they don't specify a lone pair here, meaning that it has a formal charge of 0, and so this is not satisfy. Nitrogen in the second example has 4 bonds, which means it has a formal charge of +1, so that's good. And in the third example, nitrogen also has a formal charge. It has 4 bonds and no lone pairs, meaning that it has, again, one more bond than what it prefers, meaning that it has a positive, specifically a +1 formal charge in each of these. So 2 and 3, meaning that there's more than one of the choices. That is it for the problems for the formal charge worksheet. If you find this topic confusing, maybe go back to the topic video linked in the description below. If you want to retry the worksheet with a blank page, or just look over the answer key, or keep them, or save them, or send them to your friends, check the description below. All linked in the Google Drive, all completely free. And I'll see you guys in the next one.